Okay, what's different about number 1 compared to 7 through 10? Look at your 7, look at my 1. Notice the X is now inside the triangle, right? Okay, so down here, you were solving for sides on all 4 of these. Up here, we're solving for a missing angle measure. Again, make sure you're in degree mode. I also want you to, it's probably not going to look good, I want you to get used to theta. I'm going to make that into a theta. If you can make them into theta here and there. Because on our My Math Lab, it's going to be theta. These are geared more towards like when you're teaching it for geometry, and they're still learning what theta is. So just remember from last week, we said theta is a fancy X for an unknown angle that we don't know. We don't know it at all. The good news is you start the problem the same way, regardless of whether the variable is inside or outside. So we're going to start the problem. Here we go. Draw an arrow to the hypotenuse. There's something here, so I'm going to label it H. I'm going to go to my angle that I don't know, but I'm going to draw my arc. Then I'm going to say to myself, how's the 15 positioned? Is it opposite or adjacent? Opposite, because it's really far away, not touching. So which trig function is it? Sine. So you're going to set it up like normal. Your variable will now be on the left of the equation. So we got sine theta equals opposite over hypotenuse. So the 2 problems at the bottom of your paper last week that we said, these are the 2 scenarios, X is either in the top of the fraction or the bottom of the fraction. Those are how you solve for a missing side. We're solving for this missing angle right here. So this is a totally different scenario. And although you may think it's going to be more complicated, it's actually easier. Now, on this problem, we're going to write way more than we need to, okay? Is that liquid? Okay. We're going to write more than we need to on this one. When we get to the next one, you can show less work. I just need you to know why what we need to write happens the way it happens. The sine is not attached to theta by multiplication, so you can't come in here and say, I'm going to divide by sine. You can't do that. These are connected, okay? So what you have to do, the way trig works, when you have a trig function connected to an angle, the only way to get rid of it is to multiply by what's called the inverse. You're multiplying by its inverse. Just like the inverse of addition is subtraction, the inverse of sine is, wait for it, sine inverse. This little -1 means inverse. This is what the -1 means. It means inverse. Now, whatever you do to one side, you have to do to the other. So, and I don't want you to multiply it over here because then it won't make sense. It really needs to go right here in the front. Sine inverse. And now I can see, okay, on the left, theta comes down, and on the right, I have sine inverse 15 over 24. And that's what you're going to type in the calculator. And you might be thinking, how do you type that in? In the calculator, you're going to type second, then sine, then 15 divide 24. What's it say to go to? 10th? We get 38.7. Now this was an angle measure, so that means we need to write the degree symbol. Now we wrote a lot here. You normally don't have to show this much, so let's jump over to number 2. Label your triangle, draw your arc, figure out which trig function You get cosine. All right, we're going to set it up. So cosine angle measure equals fraction bar 8/11. Now here's what I do, because I understand that I'm multiplying by the inverse and this is going to cancel. So once I recognize, okay, this is actually what I need by itself, on my paper I say, okay, I'm going to have cosine disappear from the left and reappear on the right as inverse. And then have 8/11. And then I go to my calculator. Now you can't just bump cosine over to the other side as regular cosine. The only way it appears over there is with that little -1 because it was the inverse. It wasn't the regular cosine. And then what'd you get? 43.3. And then it's an angle. Let's say we got, I don't know, something crazy. Let's say we got like 192. Let's say you typed something really wild in there and you came to theta equals 192. Or not even 192. That was a little ridiculous. Hold on. Let's try this. Let's say you got theta equals 98. What's a red flag to let me know that's not possible? Do y'all remember from geometry about triangles? Yes. What's the total?
180.
180. So you might want to go to the top of your paper maybe somewhere, and you might want to say to yourself, because this does come up down the road, you may just want to say what the total angle measure, the total of the angles of a triangle is 180. And now since we're working with right triangles, this will always be 90, which means there's only 90 left between these two. So that's another like red flag to keep in the back of your mind. The right angle will suck up 90 degrees out of the 180, which means these two angles here can only add to 90 every time. So if you ever come to an answer that is way out in left field, ask yourself, does it make sense? This makes sense. This is an appropriate answer. All right, y'all try those 4. I got ahead of myself. Those 4. You're going to find these problems go by very quickly. This paper is showing you the relationship in what's called special right triangles. You have 2 types, 45, 45, 90, 30, 60, 90. Those are talking about the angle measures. Remember, the sum of all the angles is always 180. Remember, every right triangle has one angle that's 90, and then the 2 acute angles have to add to 90. Now, something you're going to find, if you know the angles of a triangle, for instance, 45, 45, 90, what do you notice about these 2 angle measures?
Oh, they add up to 90.
They add up to 90. They're also the same number, right?
Correct.
However many congruent angles are in a triangle dictates how many congruent sides are in a triangle. So if I have 2 congruent angles, then I have 2 congruent sides. If I have 3 congruent angles, which we won't because we're dealing with not right triangles, but if I had 3 congruent angles, I would have 3 congruent sides of a triangle, meaning it would be equilateral. Because I have 2 congruent angles, 2 congruent angles, this is my abbreviation. This means congruent, which is the fancy word for equal, and then this is how I abbreviate angles. 2 congruent angles means two congruent sides. So this is always isosceles. If y'all remember that word, that means a triangle with two equal sides. Now the question is, what two sides are equal? Well, because it has a 90-degree angle in it, it's going to be the two legs. So it's an L, but they're equal. So I guess you could think of making a capital L with your hand, but then tuck your finger down so maybe it's about the same length as your, you know what I mean? Give or take. All right, so I'm going to come over here to this picture and I'm going to draw a congruent mark. This little tick mark means it's equal to this, because that's my leg, two legs of the triangle. And then here's my hypotenuse. All right, you're going to learn that there's a relationship, because every single time you have an isosceles triangle, it's going to be 45, 45, 90. Every day, all day. Every day. Even Saturday. Okay? Notice all three of these. The numbers that describe the sides are different, but do you notice the angles are the same? This is 45, this is 90, so this has to be 45. This is 45, this is 90, so this has to be 45. So they're all 45, 45, 90, okay? Because of that, there's a formula that appears when you're finding the missing sides. The leg, let me make sure I write this right, because I always have to think about this. If this is X and this is X, if they're equal, let's say we don't know what they are, but they're equal. This is X, this is X. Then this is going to be X root 2. So the leg is X and the hypotenuse is X root 2. All right, now how do you actually apply this? Okay, so look over here. Could you use sine, cosine, tangent? Yes, you can. The problem is, now that we have introduced a radical, when you use sine, cosine, tangent, it's going to give you the full decimal. You can't see the root 2 when it's in there. So now we're going to have to forego sine, cosine, tangent and actually find it using the formulas. So watch this. Have common sense when you approach it. Say to yourself, okay, this is a 45, 45, 90. Find the legs. Here's the legs. Mark them congruent. Bam, I immediately know X is 8. Then ask yourself, what am I looking for? I'm looking for the hypotenuse. The hypotenuse, look over here. You may want to write this. The hypotenuse is the leg times root 2. That's where the whole X root 2 comes in. It's the leg times root 2. So here we go. The hypotenuse, right? Hypotenuse equals leg times root 2. Let's plug it in. Hypotenuse is Y. Leg is 8. Bring down the root 2. I have nothing left to do because those numbers don't actually, become anything because 8 is on the outside, 2 is underneath. So what is Y? It's 8 root 2. Nope. That's why we can't use sine, cosine, tangent. We don't want the decimal. We want the radical.
Unless it's a complete square.
Yes. Yes. And it won't be. So now everybody try number 2. All right, did you get, these are your legs. It's a 45, 45, 90. So Y is 25. And then if I know the legs, then the hypotenuse is just the leg root 2. So it's 25 root 2. That's it. Did I write that in the right order? Yeah, this is a Y,
Yeah.
and that's an X. I need to zoom in. This is ridiculous. There we go. All right, now this one's going to be tougher. We don't know either leg, but we do know that they're going to be equal because this is a 45, 45, 90. So once I find one, I found the other one. I would start with this. Write your formula. It's the hypotenuse equals the leg times root 2, and then I would solve it. So we got the hypotenuse equals leg times root 2. The hypotenuse is 19. Pick a leg. I'm going to go with X. Root 2. I need X by itself, so this is attached how? Multiplication, so I'm going to move it by division. It's going to pop up underneath the 19. And as y'all have already learned, you can't leave it down here. So this is going to be one of those that's really ugly. So we have 19 over root 2, and it needs to be rationalized. We would multiply by what, y'all? Root 2 over root 2. And then just multiply straight across. So you get 19 root 2 over 2. Remember what we talked about, how a lot of it is the same math you already know. It's just really ugly answers to see if you cave in. Okay, so there's not any more problems because there's no other scenarios. It's either you know a leg and you find the other leg and the hypotenuse, that's the easiest one, or you know the hypotenuse and you have to work backwards to find the legs. So those are the two scenarios right there. When it's a 45, 45, 90. When it's a 30, 60, 90, it's very similar, but we do have different formulas, okay? You're going to use the phrase short leg, long leg, hypotenuse. So the hypotenuse is obviously the side opposite of the right angle. The short leg will be opposite of the short angle. When I say short, I do mean small. The smaller angle is 30, so come all the way over here. This would be the short side. This is 60, so this is the only side left, so this is the long side. All right, now, what's the formula? I don't have any room that bothers me. I'm going to write it. I guess I should have drawn. I'm going to draw that exact picture over here and write the formulas. So this is 30. And this is 60. Okay, the formulas are, if the short side's x, then the hypotenuse is 2x, and the long side is x root 3. So the short leg is x. The long leg is the short times root 3. The hypotenuse is the short times 2. Or 2 times the short. I guess I should write it like that because it's 2x. Too far. 2 times the short might be better. Now, this is corny, but it works. You might want to write it. If you know the short leg, then it's a short problem. Problem. Good grief. I'm just going to abbreviate problem. I'm running out of room. It's a short problem. Similarly, if you know the long leg, means it's going to be a longer problem, a long problem. Now, what if you know the hypotenuse? Well, you cut it in half, now you know the short, and it's a short problem, okay? So this one you have to be careful because now there's not two things, there's three things to keep up with. So looking at 4, ask yourself, go in and label SLH, short, long, hypotenuse. So here's my hypotenuse. This is 60, which means this over here is my long, this is my short. Make sure you know how to get that. And now you can look at it and see, okay, they're giving me which side to start with. Y'all gonna have to start answering in the back. I may eventually ask if you move over here so as I walk by I can like check your answers and make sure you're okay. What side do I know? Short side. So it's going to be a short problem. All right, so look up here at your formula. I know the short side, which means to get the hypotenuse, y'all are going to find I always go straight to the hypotenuse. Double it. So if the short's 5, the hypotenuse is 2 times 5, which is 10. And if the short's 5, then the long is short times root 3. It's so short you don't even really have any work to show. Let's do. What's that one? We know the short. There you go. Try 5. Label SLH. So you got another short problem. The short side's 14. So I always go to the hypotenuse so I'll never get it confused with the long side. The hypotenuse would be double. So 2 times 14 is 28. And then the long side is going to be 14 root 3. Now, what if you know the hypotenuse? Go ahead and label your picture with SLH. This is 30, so coming across from the 30 would be the short side. Then we got the long side. If you know the hypotenuse, you can find the short very quickly. Because remember, the ratio here is a 1-to-2 ratio. Whatever the short is, the hypotenuse is times 2, so go reverse. If the hypotenuse is 32, then the short would be 32 divided by 2, which is 16. Now I know the short, so I can finish it with the long side. So it's going to be 16 root 3. So those aren't bad at all. Let's jump to when you don't know the, like here's another where you know the hypotenuse. So you could fill that one in real quick. Y'all get 23 root 3 and 23. All right, what if it's a long? So this one right here, here's my hypotenuse, short and long. If you know the long side, it's a long problem. You do have a little work to do. Sometimes it works out nice and easy, and then sometimes it's it's got the radicals and they get in the way. So let's look up here. Look at the formula. The long leg is short times root 3. That's what we're going to copy down here. So we're going to copy long is short times root 3. So I just used L and S. The L is 20. I don't know S. That's Y.
That's 146 will be that's 2503. That's
See where I got that? And now I'm going to divide.
That's 124 will be an outcome. And that's 123 will be best 60. Again, your best changes for the
And then, of course, you can't leave it like that. And that's where it's ugly.
117 will be 2501. That's 124 will have an outcome. And that's 123 will be best 60. Congratulations to the Redfern team.
You have to multiply by root 3 over root 3, and it won't clean up, so you would leave it as is. And then now to double it to get the hypotenuse, the only thing you can double is the 20. You don't double both of them, the 20 and the 3. Don't do that. So it'd be 40 root 3 over 3.